Get ready for a mind-bending journey into the cosmos. We're about to explore a fascinating question. Could there be moons orbiting planets in other solar systems? And what does that mean for the potential for life beyond our own? The search for exomoons, a cosmic mystery. While we haven't confirmed the existence of exomoons yet, it's a tantalizing prospect. After all, moons are abundant in our own solar system, so why wouldn't they exist elsewhere? But here's where it gets controversial. A new study suggests that certain types of stars might not be able to support these moons for very long, which could have huge implications for the search for extraterrestrial life. The Earth's moon, a unique case. Our moon is a special case. It's relatively large compared to Earth, and its presence has played a crucial role in making our planet habitable. It stabilizes Earth's axial tilt, creating a climate and seasons that are conducive to life. It also generates ocean tides, contributing to the biodiversity and richness of coastal regions. The focus of the research. A recent study, titled Tidally Torn: Why the Most Common Stars May Lack Large, Habitable Zone Moons, delves into this very question. Led by Sean Patel from the University of Texas at Arlington, the research examines the conditions necessary for exomoons to exist around M-dwarfs, red dwarfs, the most common type of star in the Milky Way. The challenge of red dwarfs. Red dwarfs are small and dim, with their habitable zones much closer to the star than in brighter star systems like our own. This proximity has consequences. Planets in these zones are likely to be tidally locked, which could affect the stability of any potential exomoons. Simulating the conditions. The researchers used N-body simulations to study the stability of rocky planets with moons in these conditions. They varied the host planet's mass and semi-major axis to determine when exomoons become unstable. Their findings suggest that these exomoons are unlikely to survive for long periods, especially around certain types of M-dwarfs. The results: a bleak outlook. The study's results indicate that Earth-like planets in the habitable zones of M-dwarf systems will likely lose any large moons within the first billion years of their existence. The type of M-dwarf matters, with different classifications affecting the location of the habitable zone and, consequently, the strength of stellar tides and their influence on exomoons. A rare exception. However, there is a potential exception to this rule. A large moon could survive for up to 1 billion years if it orbits an Earth-mass planet around an M0 dwarf. In this scenario, the habitable zone extends further, weakening the stellar tide on the host planet and allowing the moon's tide to play a more significant role in stabilizing the system. The future of exomoon detection. The study's authors acknowledge that while rare, some exomoons could persist for longer periods, and smaller moons like Ceres or Phobos might survive undetected. The future of exomoon detection looks promising with the potential construction of the Habitable Worlds Observatory and the upcoming Giant Magellan Telescope, both of which could revolutionize our ability to directly image exoplanets and their moons. Beyond red dwarfs. While this study focused on M-dwarfs, there are other types of stars with habitable zones further from the star, where exomoons might survive for billions of years. These moons could potentially make their planets habitable, much like our moon does for Earth. Some of these moons might even be habitable themselves, a possibility we're exploring closer to home with our own icy ocean moons. The big question. So, what do you think? Are exomoons a viable possibility for supporting life, or are they simply too fragile to survive in most systems? Share your thoughts in the comments below. The search for extraterrestrial life is a fascinating journey, and every new discovery brings us one step closer to understanding our place in the universe.